Testing, testing. Hello, everybody. Okay, yes, it's working. Hi, everybody. Welcome to a special Friday edition of Astro Bookshelf Hangout. I think we're calling it now with Dr. Brian Keating. Earlier this week, he had an awesome stream with some amazing people that we're going to summarize here for you today, as well as we're going to just take some general questions from you also. I put the link to the full stream that he did in the description box of this video. But before you go there and watch the whole thing, which you must actually go do, we're going to talk a little bit about it here together, Brian and I. It's a special Friday stream because I was supposed to be having another hangout yesterday with the Lisa team, but I had a tropical storm to deal with, and it knocks out internet. Apparently, I live in an area where just a small breeze knocks out the internet. The storm wasn't bad. We've had worse thunderstorms in the summer in Florida here all the time. So we just got some wind, a little bit of wind and a lot of rain, but I had no internet. So one can't, no matter how good one thinks one stream is, you're not doing anything without internet. So thank you, Spectrum, on behalf of Deep Astronomy. Okay, so I am streaming on all the things. By all the things, I mean all the things. YouTube, Twitter, Twitch, Facebook, and I think that's all of them. Is that all the things? You can't do Instagram because Instagram, right? They just won't let you. But Periscope, that's the one. Twitter, all of those. And I'm looking at all of the chat. Most of you seem to be from YouTube. So Galaxia, hi. Peter's here. Gregorius is here. John Suffel from our good friends in the UK is also here. And Larry Keys from the West Coast. He's finally able here. Hi, Larry. Gosh, it's been a while. So it's good to see your name in my chat. So welcome, guys. Joining us Galaxy says she's like Astro Coffee much better. Okay, fine, we'll call it Astro Coffee, but it's like Astro, but we like to talk about books, not research in this particular hangout. So let me bring up Brian so I can stop mumbling. Hey Brian, you there?
Yeah, can you hear me, Tone?
Loud and clear, dude. Loud and clear. So how's it been going with you in California? It's only lunchtime there where you are.
Yeah, I have yet to eat. I'm waiting to eat until after we finish this conversation. So I'll be grumpier than normal.
Oh, so you'll be hangry on me. Is that it? Hey, Tom Van Scooter, it's good to see you from Twitch. Yeah, so just, okay, we got to get through this before Brian gives us all a hard time. So you've been having great debates, apparently.
Yeah.
Without us, right? So you went out and had a great debate, and you shared it with your closest friends. Why don't you tell us a little bit about not only what the debate was about, I guess it's really meaningless topics like you guys talked about the nature of the universe or some small piddling stuff like that. But you had some pretty good people there. Tell us a little bit about it.
Yeah, we had a knockdown, drag out, brawl with some all-star, no pun intended. Actually, fine, pun intended.
Funny, yes, we love puns here.
We're gonna lean into it, Tony.
That's right.
With a bunch of the brightest people in the world, including Janna Levin, who I did an earlier that day podcast live with her, which got a lot of attention for her new book, Black Hole Survival Guide. We'll talk about that next week, maybe.
Oh, good. Yeah.
Sara Seager, who's written another wonderful book called The Smallest Lights in the Universe. And then I had my friend Adam Riess, 2 or 3 time guest on the show. He came on to as well, and there was a battle royale between him, Wendy Freedman, who is responsible for the Hubble Space Telescope key project. In fact, one of the main reasons Hubble has a diameter of its mirror of about 100 inches, 2.4 meters, for those of you playing in Europe, that instrument was basically set up to do the work that she ended up doing for this key project to measure the Hubble constant.
That's right. That was its reason for being. That was its justification for getting built.
Yeah. And then serendipitously, it discovered all sorts of other things like the deep field, the pillars of creation, exoplanets, et cetera, et cetera. But I couldn't miss the opportunity to take these, friendly competitors, but they're competitors. And then I had David Spergel, who's a friend of mine, colleague on the Simons Observatory, and he was one of the leaders of the WMAP satellite. And so there's a lot of controversy, or as Captain Quinn might say, maybe controversy, I don't know, about the value at which the universe is expanding. So, no big deal, just small things like that. So they had a battle royale. It was so much fun. And at the end, we agreed to both do it again because we're celebrating the 100th anniversary of the E-Great debate, the Curtis Shapley debate. We're celebrating the 30th anniversary of the Hubble Space Telescope's birthday and the 20th anniversary of the International Space Station. So, you know, what else could you want? And they had this fantastic thing. I want to encourage everybody, first of all, while you're watching on Tony's channel, please go to my channel, Brian Keating, Dr. Brian Keating. I'll put a link to it in the...
There's a link in the description too.
Yeah, so click on that. Subscribe to my channel, please. Everybody needs a little exercise of this finger, so do the clicking, do the poking and the prodding. There you'll also see a link to enter a contest, which just, you know, asks you to subscribe and to my newsletter and so forth. And then I'm using that as a vector, I don't know, a funnel to give away signed copies of Janna's book, of Sara Seager's book, of my book, a little book called Losing the Nobel Prize, which you may not know because I'm just surrounded by images of it everywhere I go. And then also a signed paper of the prize that won Adam Riess his Nobel Prize, signed not by me, but by Adam himself. And then Wendy's paper, which who knows, she could be the next woman to win the Nobel Prize in physics for her work. And she signed a paper, the key project paper from 2001. So 2 signed papers by these top geniuses in the field of astronomy. No one better than the 2 of them, in my opinion. 2 signed books by the greatest writers in the heavens. So please go there, subscribe to my channel, Dr. Brian Keating. Click the link that says King Sumo. That's my friend Noah Kagan's. Just funnel that will give me your email address and enter you along with, there's already 115 entries I saw to win all these prizes. So please do that. I'll plug it. I want to give away these wonderful gifts that were personally signed by Nobel Prize winners and friends of mine.
Yeah, I love that idea of signing papers. Could you imagine if you had a copy of Einstein's 1905 paper signed by Albert Einstein? Wouldn't that be something?
It's $80,000. I actually looked up, Tony. You'll be interested to know. So Hubble wanted to win the Nobel Prize. He advocated very strongly for it. When he didn't win it,
Edwin Hubble.
Edwin Hubble, right? Yes, that's right.
Not the telescope, just
not the telescope. That's right. So he was nominated, and then he died, and he wasn't able to actually ever be considered for it. We don't know if he would have won it had he lived another couple of years. But Adam was among the 3 astronomers that became the first observational astrophysical observers that used telescopes to win the Nobel Prize. And
wow, I guess I hadn't thought of it that way. That's
one winner. Adam actually loaned me his Nobel Prize. So if you do enter the contest, you will win this Nobel Prize, which is also edible. It's a form of Hanukkah gelt, but maybe I'll send that.
Hanukkah gelt. Do they? Is that true? You can buy Hanukkah gelt with the Nobel Prize winner coins. Oh, that's
this one's 9 years old. So if you do win it, please don't eat it.
Oh yeah, well, all gelt. You know, if you play dreidel at all during Hanukkah and you win the gelt, it's always 8 or 9 years old.
That's right.
It's not good chocolate. You're not going to be getting the good stuff. So that's pretty cool.
Yeah.
Anyway, I just want to comment. Neural Net is commenting on Twitch that imagine having to build something that works for 30 years. What a feat! It was a feat, but you know they didn't build it to last 30 years. It got repaired 5 times, so that helped a lot with it staying up there. But other stuff has stayed out there for almost 30 years, like the Soho telescope, which I've told you about many times in the past. So I just wanted to get to that comment because it's a good point.
But Tony, before we go on, I do want to mention that there are papers for sale, and actually I have seen a friend of mine owns a copy of Hubble's, I think it's 1933, or it's based on the 1923 and 27 observations. And it's not even signed by Hubble, and it's $70,000.
Wow, so it's not even signed. It's not even signed.
It's not even signed. Yeah, and you can't get it signed now.
Why is it worth so much?
Go for a lot. So actually, Adam asked me, "Are you really going to sign it or give it away, or are you going to sell it on eBay?" And then I replied to him, "Adam, I'm going to see who gets more of a higher bid on eBay, your paper or Wendy's, and then I'll sell the other one."
Okay, I got a comment because it just happened. Somebody rated the channel on Twitch. I want to thank you guys for joining. You are watching a hangout between Dr. Brian Keating and I. We're talking about his stream that he did on Tuesday, where he had a great debate with a lot of top-notch astronomers and cosmologists to talk about the great the nature of the universe. And we're going to get to a summary of that right now. But right now, we're just kind of introducing ourselves and getting started. So welcome to everybody who rated the channel. I appreciate it. And I am looking at your comments. So, all right. So here we go. so tell us. So back to your stream on Tuesday. What is, in fact, I'm sure you settled it. You've settled the debate, the nature of the universe, and what's the contention about it?
So really, there were two very strenuous debates, really between Wendy Freedman and Adam on one side, debating each other, and then David Spergel on the other. And really, it comes down to what is the value of the Hubble constant. It's something that Hubble himself was obviously very curious about. And I made some slides, and I'll send the copy of the slides and the transcript to everybody who registers. I had the talk transcribed by some lowly paid graduate students. No, I paid for it to get transcribed on the internet somewhere. So I'll send you that. But it's the first time that all three of them have ever been together debating this. And I showed Hubble's original data that he used to very sort of bravely extrapolate from just a few samples of galaxies relatively nearby that the universe is expanding, and that its expansion was expanding enormously rapidly. In fact, it was way too rapid. It was about 7 times larger than the currently accepted value. So, and it was presented without really characterizing how uncertain the results were. So we were all joking, if our students turned in data that looked like Hubble's, they'd probably get an F. But then we talked, so Wendy and Adam were debating because they have two different techniques. Obviously, Adam uses techniques related to supernovae and what are called Cepheid variables. And those were, of course, the very first objects that Hubble used, thanks to Henrietta Swan-Leavitt measurements and what we now call Leavitt's law in 1911. We now know that Cepheids can be used as rulers that stretch out across the entirety of the universe, more or less, to provide an accurate measurement of distance based on how rapidly they pulse on and off. So what was really magical about the evening on Tuesday night was here I had Adam Riess and Wendy Freedman and Janna Levin and Sara Seager and David Spergel, all these like brilliant scientists. 3 or 4 of them are National Academy members. I think all of them are best-selling authors in the case of Janna Levin. And she has this wonderful new book. And for those of you who like podcasts, Tim Ferriss featured her twice this year on his podcast. I'm hoping
that's a big podcast.
That's a very good podcast. And so I'm she's just so gracious. And she and Wendy Freedman and Sara Seager were talking about the impact of women in astronomy. And so there were 3 men and 3 women, and we were remarking how different astronomy is than when Henrietta Leavitt was this deaf astronomer working basically undercover as a computer, taking data, and in her spare time becoming one of the world's foremost astronomers. Sadly, not living long enough to see the fruits of her labor really blossom as it did with Hubble, characterizing the expansion of the universe for the first time with some reasonable level of accuracy. Of course, he was off by a factor of 7. So we talked about why was he so far off, why that wasn't such a bad thing, and then how it later informed people like this guy over here, Albert Einstein, and made him change his opinions about the nature of gravity, which is Janna Levin's specialty. So we had this incredible dialogue about the history of astronomy, the history of women in astronomy, the impact of observational astronomy on theoretical cosmology. And finally, we had this very vigorous debate on who's right. Because right now there's a 5 sigma, which means, a part in several million chance of happening accidentally by statistical fluke. There's a 5 sigma discrepancy between measurements done by people like Adam and people like Wendy using starlight of various kinds, either supernova starlight or what Wendy uses called red giant stars. And then what David Spergel and I use, which is using the early universe's expansion rate propagated forwards in time to the present day to compare to these 2 different values. And you get a completely different value. It's like you measure one of my 2-year-old twins and you say that they're going to be so tall when they're fully grown, and then you come back and check on them based on their forecast when they're young, you'd say that they should be, 6 feet tall maybe. And then it turns out they're at least 20%, maybe even bigger. So they're 6-7 feet tall, something like that. And in the case of the astronomical, that can't be done by fluke. According to statistical probability, the chance of getting this wrong is incredibly low. So it was interesting to fight it out.
But so what that means is somebody's wrong, right? And they're
both extremely confident.
Right. But I mean, that's the conundrum here. When you know something to within such small error bars, according to your theories and procedures, then there's got and they're wildly different. Then you're probably, I think, and I'm just a neophyte here, you're probably not measuring what you think you're measuring in one of the two situations. Now, if I had a guess, I would say the Type 1A supernova people probably have a little more work to do, because I think C-field variables are certainly understood, but the Type 1A supernovae, maybe there's something there. I don't know. What do you think?
Yeah, well, that was the interesting thing, that they started off, debating not necessarily who is right, but who's wrong, and who's likely to be wrong really depends on, kind of your camp. But what's interesting is that in the middle of it, Adam is like texting me new data to show in the conversation that had really recently come in, and that was, sort of revelatory for me to see how overwhelming the evidence was in favor of the supernova data, which is the opposite side of the case that I would take from the cosmic microwave background side. And so it was just really amusing to me to see, like, there's this overwhelming evidence. And I've been thinking a lot about, in this political season, we haven't talked since before the election.
Right. Yeah.
What's the difference between scientific debates and political debates? And I think the hallmark of what I see is that we have a desire in science to go where the evidence goes. And if the evidence is overwhelming, as we think it might be, we should change our minds. But right now, the evidence is overwhelming on both sides. And I think the ultimate resolution that I came in with beforehand, I totally overcame, in that I now think that it's likely that there's some form of unknown, previously undiscovered physics at work that we have not yet fully understood, but we will have some incredible new theories coming out about it, thanks to the work that these two different camps are doing to get very precise data. And now the difference is who's more accurate, who's actually accurate, and how can they differ so much? And right now, it's not at all clear who's going to win, but I think it's one of the most exciting developments in astronomy currently.
I actually think you're right, and it makes perfect sense that there's probably something else at play here. Because remember, when Adam Riess won his Nobel Prize, it was based on a completely unexpected result. I mean, you remember this. People were so sure that they were going to find a deceleration of the universe, in other words, a slowing down of the acceleration of the universe, that they actually called their study that, measuring the deceleration of the of the cosmos, or something like that. And not only did they not find that, they found that the opposite was happening. There was an acceleration going on, and it stunned everyone. So, I mean, it makes sense to me that there's not only were we not, based on everything that we had known up to that point, we were expecting a decelerating universe. We didn't get that. That I think there is something more at play, probably related to dark energy, because it's so ill defined. Some of the parameters in it that are involved in this. Oh, well, that's not true. The parameters aren't ill-defined. It's what they might physically mean that is, right, I think, is still being worked out. But that's a really good point. So what did the you said you had a WMAP guy there. What was his name again?
So that's David Spergel. So he
David Spergel
is one of the foremost cosmologist that works on. He was one of the original founding team members of the WMAP satellite.
WMAP, let me just say real quick, Wilkinson, Michelson anisotropy probe.
Yeah, Wilkinson
microwave. Sorry, anisotropy probe. It was the precursor to the Planck instrument that measured the cosmic microwave background, tiny variations in temperature of that background. That's what it is. So I'm sorry. Go ahead. I just want to.
Yeah, it was actually the most cited instrument in terms of papers and data that came out of it. It was the most cited result of the decade between 2000 and 2010. Across all of science. It's really amazing. Their results really stole the thunder from the Planck team. And the Planck team was more or less, in some sense, maybe I can say it because he wouldn't say it, but relegated to confirming a lot of what the WMAP satellite came up with. And I'm particularly proud to be connected to it, because David Wilkinson, is my grand advisor. He was my PhD advisor's PhD advisor. A wonderful man. Unfortunately, he died just before the satellite really got into orbit back in 2001. He's a great man, great scientist. Worked with Bob Dickey and Jim Peebles, who ultimately won the Nobel Prize last year, but they had been scooped by Penzias and Wilson, the team, including my grand advisor, David Wilkinson. But so David Spergel keeps up the kind of the mantle of leadership in cosmology through his work. Now he's the director of the Center for Computational Astrophysics, which is part of the Flatiron Institute, which is part of the Simons Foundation that I'm involved with, which supports my Simons Observatory telescope that my colleagues and I are building in the Atacama Desert of northern Chile.
Now, correct me if I'm wrong, but wasn't John Mather, the current, he's the project scientist for James Webb Space Telescope, wasn't he a member of the COBE
Yes.
mission? So that's, so just so COBE was the precursor to WMAP, which measured the microwave of background. So we had COBE, WMAP, and then Planck were the three big measurements.
Right. And now we're planning fourth generation instruments, and very few of them will be located in space. Actually, now we think we can do most of what needs to be done from the ground, including including from the cosmic microwave background side, and even from the Large Telescope. So as we said, Wendy Freedman pointed out in our conversation the other night that this telescope was made to really go after looking at Cepheids, but what she's doing now are looking at these red giants, which are these ancient stars that are in the outskirts of this Hertzsprung-Russell diagram that kind of plots the color versus brightness of different stars. And these red giants kind of inhabit this special place that they're very old, and their properties are very simple. They're not complex stars. They're burning, fusion in their cores. I forget exactly what they're burning, but their fusion reaction is much more well understood than some of the issues with the type 1A supernovae, which are these cataclysmic explosions that we think are related to what's called the Chandrasekhar mass companion white dwarf and a larger star that eventually accrete the white dwarf and cause it to blow up. And then that explosion can be used as a standard candle. She uses these red giant branch stars, and she gets a value that's not inconsistent. It's a little less precise than what Adam's group is doing, is not only the supernovae, but also Cepheids, and trying to understand them better. And he claims he can get down to 1% in terms of the accuracy of the calibration of the measurements that he's doing with these type 1A supernovae and Cepheids. And now they're adding in a third or fourth maybe now, which is gravitational time delay and so-called strong gravitational lens systems. We talked about that, this instrument or this project called Holy Cow, which is, worse acronyms have been invented.
I know, and it's a real one. That's really it.
Out there, yeah. Bicep I invented, but I can take the blame for that. But nevertheless, this was just a phenomenal discussion for people to be really gathered around this notion of what is correct. Is it going to be amongst the optical astronomers, these old dying, these old ancient stars, these red dwarfs, or will it be the exploding cataclysmic stars, or will it be the 110-year-old Leavitt's law Cepheid variables? Who knows? They're debating it. And then in comes Planck and WMAP and say, wait, you're both wrong. You're all wrong. We're 5 sigma away from you. And the physics of the early microwave background, it doesn't get any simpler or, than that. It doesn't mean easy. It just means the physics behind it is simple general relativity. It's simple plasma physics. We think if we are getting a mistake there, then all bets are off. Then we don't understand what the cosmic microwave background is. Then we wouldn't understand how the universe is evolving in the so-called lambda cold dark matter scenario. So there's a couple of proposals that say you're both right. It's kind of like when my kids fight and you want to make sure that they don't kill each other. So you say, oh no, you're both right. You take the cookie, you split it in half, take the Nobel Prize, split it in half.
No, not in science. Sorry.
Well, one let me ask you this. Where they both could be right, Tony, is if there's some new physics, neutrino physics.
Or maybe I'm being too simplistic. Yeah. In fact, I know I am, but let me just say, could it not be that with the cosmic microwave background, you're measuring something from the early universe, 500 million years after the Big Bang, something like that. And then you're looking, and with the other measurements, you're looking at a period of the universe much more recent. Isn't it possible that the universe expansion, acceleration is not linear? It's not the same throughout the history of the universe. For example, in the early universe, perhaps it really was I forgot what is it, 67 kilometers per second per megaparsec? I forget the
in the CMB, yes.
Right. And then in the microwave, and then in the type 1A supernova camp, it's a different number. couldn't it be that the acceleration is not the same throughout the history of the universe? And
but
that
then you
they're
have to
both right.
Yeah, so that's right. So, but then you have to explain why did you get a different? I mean, it's the same phenomenon. It's the universe expanding under very simple ingredients. Of course, it's extremely complex, and I have nothing but the highest respect for my colleagues that calculate these numbers. But in cosmology, once you know what the universe is made of, its destiny is completely dependent on its density and what it's made of. And we know properties of hydrogen very well. We know what temperature hydrogen, fuses at, if you will. A proton combines with an electron to make hydrogen as an atomic species. And yet, the simple ingredients with a little bit of hydrogen, some neutrinos sprinkled in, dark energy is almost irrelevant at this early epoch. And then dark matter and ordinary, radiation, photons, etc. It's a very simple universe. You plug that into the Friedman equations, and you get H. You get the Hubble parameter, and then you ask, well, what is the Hubble parameter, which is the Hubble constant as a function of time? What do you forecast it will be? 1 billion years, 5 billion years, 13.8 billion years after the Big Bang, and you come up with two different numbers, which are separated by this gulf in probability space of 5 sigma discrepancy.
So this discrepancy is a function of time, and it takes into account the density of the universe at various times. So you could, so what I just said is already been dealt with. Right?
Yes, that's the crux of it. Right. So people now are trying to come up with rationale for how could it be that they have two different values and be consistent. In other words, say each one is making a very accurate and precise measurement, but they're measuring two different things. In other words, what we thought of as the expansion rate, actually we forgot to take into account how dark energy evolves. Maybe it was really, really big early on, and so you would forecast the Hubble parameter to be getting smaller with time, just making that up. And that's what we see with the CMB forecast. It should be smaller today based on the value that it was back then. But the fact that we can measure this, when I was in graduate school 20 years ago, we didn't know if the universe was 10 billion years or 20 billion years. Now and that relates to the inverse of the Hubble constant is the age of the universe. So that means we had 100% error in the Hubble. And this is not like in 1960, 1930. This is in 2000. In 2000, we had 100% uncertainty in the Hubble constant evaluated today, which is why it was one of the key projects for the Hubble Space Telescope. Mm-hmm. And instead, now we've got a 1%, 100 times reduction in uncertainty, before this discrepancy. Now, the discrepancy could be real and we can resolve it, and it could still be right at the 1% level. It's just one team is right, one team is wrong, or there's some new physics that we didn't understand because we didn't have the precision that we now have, thanks to the understanding theoretically of Cepheid variables, thanks to how we understand how supernova behave, thanks to how we understand these red giants and how we calibrate these stars. So the interesting thing about the stars, so behind me, I've got a picture taken by Margaret Burbidge, the famous late, unfortunately, Margaret Burbidge, who deserved a Nobel Prize, in my opinion, for her work with her husband, Jeff, whose office I am currently in, or he occupied this office before I did. Willie Fowler, who did win the Nobel Prize in 1982 for his contributions to the understanding of stellar nucleosynthesis, which is what Margaret and her husband and Fred Hoyle worked on. Now, what's so interesting to me is that this galaxy behind me over there is a galaxy that of the type that Wendy Freedman's team would use in the key project, but now they're looking even further out. And so you don't have any control where a supernova goes off. So imagine a supernova goes off and it goes off right in the middle of the core of the galaxy. That's where the most stars are anyway. So it's the highest probability for us to see a supernova of the type that Adam visualizes. Now, to measure that with a CCD camera, like the kind that he's using, oftentimes he can't really separate the actual supernova that blew up from a surrounding star. There's too many stars there. But Wendy, there's literally billions of red giants all throughout that image over there. And so she can pick one far on the outskirts that's still part of that galaxy. So it's at the same distance as the bulk of those stars, but it's not confusion limited by other stars in the same pixel spraying light into the telescope that they're looking at. And so for that reason, she thinks she can get better accuracy and avoid the so-called crowded background effect. So that was one of the topics. The other topic we talked about, because I will get hungry and I will start to eat my Einstein, my chocolate, 11-year-old chocolate. We don't want that. We don't want me to die on air. The other thing that was so fascinating, in addition to the brilliant history of women in astronomy, that these 3 brilliant women and 2 brilliant men, plus me, were reviewing, was this history of how women contributed to astronomy, the great kind of unsolved problems that they were able to solve. But also, we talked a lot about the nature of things like black holes and whether they could contribute to understanding these tensions. So right now there's a lot of different tensions. So on Tuesday, I'm talking to Lenny Susskind, the famous Lenny Susskind, who wrote a book, called Black Hole War, about his battle with Stephen Hawking. And so I'm going to do that live. So people, tune into my channel, subscribe. Again, use your finger. You've been sitting there. You're too complacent. Take your finger and subscribe. Click on that link. It'll take you right to subscribe to my channel. Hit the bell, and you'll go live. And I'll take your questions, my friends here on Deep Astronomy. I'll try to get to all your questions for Lenny Susskind, because he's never done a live stream like this ever before. Yep, that's his previous book.
I have this one. I don't have the other one.
Yeah, I've been listening to the other one and reading it. He's just a supreme, and he just takes no nonsense. He's such a gruff, scruffy guy, but he's incredibly brilliant, influential, and he's generous with his time. So that's Tuesday morning, 9:30 a.m. Pacific time, 12:30 p.m. On Monday Eastern time. Tune in and ask him live questions. So you got to subscribe and hit the notification bell. And again, please also sign up for this contest. I'll put the link in there again for you guys to sign up in the live chat, because getting signed papers by Adam Riess, by Wendy Freedman, and signed books by Janna Levin and Sara Seager, it's really too good to be true. So I'll send those out. The only thing is you have to live in America. I can't afford that. I'm just a simple public employee of the state of California. So unfortunately, but we're welcome to sign up and send me questions. And I will send everybody who signs up, I'm going to send you a copy of the slides I showed in that talk and a copy of the transcript service as soon as my friends I think they're in Barbados or somewhere, typing away an hour-and-a-half long transcript with all the kind of goodies thrown in. It's not an easy job. So when they get that done, I will send it to you for free as well for everybody that enters, because that's digital, easy to ship.
That's awesome. Yeah, and it's gonna get better to do that. They got AI now. I think both YouTube and somebody else has got some AI that'll do your transcripts live, so you can have live. So that'll get easier as time goes on. But yeah, it's a real challenge right now. I just got a comment on this term, confusion limited. It's for those of you who know telescopes, the defining parameter of a telescope is to be diffraction limited, right? You don't want your optics to be flawed in any way. You want the physics of light to be the thing that limits you in your observations. Well, I try to live a confusion limited life, but
my confusion.
I am far from it. I am not confusion limited. I am definitely not confusion.
My confusion is unlimited.
I love that term. I've never heard of it before. So in the confusion limited domain. All right. So Brian, you got to go?
Yeah, I got to go in about a minute or two. Let's take some questions before I go, because I love you.
Yeah, ask us some questions, and I will I will stick around for a little bit myself after it's over. Let's see if I can find you guys ask any questions first of all. I'm scrolling through my chat. You scroll through yours.
Yeah.
Let's see. Now there's people just chatting with themselves. Here we go. Here's a comment from Galaxia. Interesting fact: Edwin Hubble did not know he was observing or measuring the expansion of the universe. George Lemaitre explained it to him.
That's right.
And
actually, he thought that. Yeah, certainly Einstein didn't think he was observing it, and he called him basically a piece of for Lemaitre's ideas. So interesting. Of course, he was a priest, and you'd think a priest would want to bolster evidence for the Big Bang because it kind of comports with. I'm not going to get religious here, but some people claim it as the Pope claimed it as evidence and proof of the account of Genesis, which I think is total nonsense. Even though I take the Bible seriously, but that's a totally different.
Actually, topic. Yeah, it's kind of a myth that the Catholics have had a lot of cosmologists in their employ throughout the centuries, and Lemaitre being one of them. But it's not true that they're trying to disprove anything. They're just trying to learn more about the cosmos. So that's something I like to point out periodically. I married a Catholic. I learned a lot about it from her. Charlie's commenting, the Hubble constant has been a source of vigorous discussion for many years. By vigorous, I mean really heated. Indeed. Larry Keese is commenting, that podcast that Dr. Keating led was just incredible. Such great names. If you have not listened to it, please go do so after we're done here, because it is amazing.
Yeah. And I'll put in also, I'm putting all these things on iTunes. I've got some great help here. If people are interested in getting involved with the YouTube channel, I can use help with promotions, with marketing, with thumbnails and stuff like that. I'm getting 4 Nobel Prize winners are coming in the next month, guys. I've got Sheldon Glashow, who's discovered the electroweak theory with Steven Weinberg. He's coming on. I've got Barry Barish of LIGO. I've got Ray Weiss of LIGO. And I'm putting together, my next book is going to be about lessons I've learned from Nobel Prize winners, instead of, how I can go from loser to winner, I suppose. But it's going to have all my interviews with these wonderful Nobel Prize winners, Adam Riess, Duncan Haldane, Carl Wyman, and the commonalities and kind of their tactics, tricks, and tools, sort of like Tim Ferriss wrote this book, Tools of Titans. I'm working on an analog of that called Lessons from Laureates that I hope to put out before the end of the year. And I'd love to get help on that from people that are interested. So send me an email, sign up for my newsletter at briankeating.com, and be in touch. I would love to get help with it.
Yeah, man, this is great access, guys. I can't tell you what a great resource this is for you. These are not just anybody that Brian's talking to. These are big names. These are the biggest in their fields. I couldn't help noticing in your book behind you that right next to Jackson's, the E&M book, which gave me grief, more grief than I can say. You've also got Kip Thorne's Gravitation book. Now, I happened to read that just right after it came out. I read it in about a week. How about you? Have you gone through it yet?
Yeah, I read it every time I'm in the bathroom.
Yeah, exactly. This is a book on gravity. Literally, Kip Thorne has written the book on gravity, right? And it is like a 1,000-page book that's sitting there behind him. Kip Thorne is somebody you should talk to as well.
I have him scheduled. He has.
You do?
Yep, he's coming on the show hopefully in January. So that'll be. All the cool kids. I know. Yeah, that's going to be amazing. I'm going to talk to him about also his work in the movies. But you're right. That book, Meisner, Thorne, and Wheeler, it doubles as a weight. Instead of going to the gym, you could exercise using a gravitational field. So yeah, guys, this has been great.
Kip Thorne's a rock star. He really is. Well, John Selfa has a real quick question. Then you can go. If the Hubble constant is shown to be wrong, would that negate the need for dark energy?
Oh, if the Hubble constant is wrong. So you can have a Hubble constant without dark energy whatsoever. In fact, that's what we thought it was. That's the way that we thought things were back in the early, back before we knew the existence of dark matter, dark energy. We, that's all we really supposed, is that there was no dark energy and that there was a Hubble constant. So we know there's a Hubble constant. We know the universe is expanding. There's no doubt about it.
Yeah. So, okay. As far as what dark energy actually is, though, who knows? We'll talk.
Yeah. Even Adam will say, we know less about that than we know about dark matter, and we don't know that much about dark matter.
That's not saying much, is it? I know.
It's exactly right.
Dr. Brian Keating, author of Losing the Nobel Prize, also runner of his own YouTube channel, and the host of the podcast. Can give us the name of your podcast again? I always
get it wrong. Into the Impossible podcast.
Into the Impossible.
I'll put that in the chat room as well, and then I will put in I'll put in a link to join my mailing list, please, and then you can get that there. And I will put a link to this contest. So I'll put that in the chat and people can look that up. Please tune in on Tuesday morning. I did an interview with Cliff Will, who's a fellow Floridian that maybe who wrote a book about the all the various experimental pieces of evidence that give us rationale to believe that Einstein was right. And it's called Is Einstein Right? Still Right. After all these years, is the old one, is Einstein, is he still right? And it was funny because I had Adam Riess on my show, and oftentimes I get people that write me things, and say, Dr. Keating, I've got this great idea. Can you please help me? And, if I'm right, Einstein's wrong, but I'll share the Nobel Prize with you. And so far, I haven't, really found someone I'm going to take that up with. But he said he gets those letters, Adam did, and one day he answered it, and look what happened. He won one of these things. So stay tuned. Keep in touch. Yeah, I really would love to keep sharing all these cool videos with people that are really just giving me inspiration as a physicist. So don't forget to enter the competition. I'll put that link one last time in the chat room, and then I'll be on my way to eat some humble pie. We'll see how that works.
Okay. Yes. All right. Well, thank you, Brian, for taking time out. We'll probably be back next week. I don't know if your schedule permits, but if so, we'll be back next week.
Yeah.
And please, guys, use this resource. Brian's doing amazing things, amazing work, and you're going to get access to these guys, and it's really no better way to do it. So definitely take advantage of it. Brian, thanks for taking time out.
Thank you so much, Tony. Have a great weekend, and I'll talk to you next week.
All righty. Thank you. I'll stick around for a little bit, guys. Oh, don't forget to stop your stream, Brian, on your channel.
Oh, yeah, I will. Oh. I'll just put one more thing in the chat room, and I am out of here.
All right.
Bye, guys.
Okay, guys. All right. So Hans is commenting, dark energy is like anti-gravity, pushing everything away, right? The universe is like a boiling soup of areas that contract, forming stars and galaxies and others that expand. That's right. That's a good characterization of it, Hans, I think. So Neil Yu, it's good to see you on Twitch. And Neil's actually asking, and like, what about the time before the Big Bang and whatever's outside of our universe? Neil, dude, come on, man. We have got to get the handle on what we're inside of first. Then maybe we could talk about time before the Big Bang, if that question even makes sense, or stuff outside the universe, which also doesn't make sense. Now, what I didn't say to Brian, but, is that Leonard Susskind, who he is about to interview, is a big proponent of this cosmic landscape. That's this book that I just showed you here. It's like String Theory and the Illusion of Intelligent Design is the subtitle. But really, it's all about this universe of universes, right? Where there's this big cosmic landscape. It's not too different from the MiniWorlds theories that we've been hearing about lately as well. And so he's a big proponent of that. And I don't feel like we are near ready to be talking about that stuff, right? Because we don't even have a handle on what's going on in our own universe. This idea of inflation in our own universe is also driving us nuts. So I would rather us getting a good grip on how things work in here, and if it leads us to somewhere outside the universe, then okay, so be it. But I think we're going to need to stay kind of constrained into our own universe. Neil, that's my little take on this. He's also commenting, Neil is on Twitch. People know a lot about time, but it's still mysterious how it runs at different rates. So wild. I know we're reaching the limits, aren't we, of our ability to really conceive and conceptualize this stuff with our brains. I think our biology lets us down a lot. In fact, it even misleads us. We're reaching a point in physics. I was talking about this with Charlotte the other day. We're reaching a point in physics, I think, where common sense is starting to become a barrier, right, to understanding the universe. We need to be able to move past the perceptions of our brain. Our brain does so much filtering of the universe that we perceive that we need to somehow start to work on how do we intellectualize the universe without using those filters so much. As an example, and I know this is a silly example, but when we look at things with our eyes, there's a lot of filtering that goes on from the time the light enters our retina until it gets to our brain. The mind has done a lot of things to alter what we're actually seeing to something that makes sense to it. With hearing, if you ever did you know, I only learned this because I edit podcasts a lot, the Space Junk podcast in particular, but when I edit a podcast, when you talk, when you use words in a sentence, there are no spaces in between the words. Did you know that? It is all one long audio wave, all one long audio waveform sentences, and the pauses like that are very exaggerated and long. But our brain, when we listen to someone talking, put in the spaces in between the words so that we can make sense of it. It's just one long stream of audio. So that's our brain once again helping to make sense of the universe through our senses. So I propose that, or what I have been thinking about, I don't propose anything because I'm just me, but the 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 way we need to start thinking about physics and the universe from here on out is we're at a point where we need to somehow shed these perceptive limitations that our brain puts on us. I don't know how to do it. I don't even know if it's possible. But things like common sense kind of have to be set on the shelf for a minute, because, and I have as big a problem with this as anybody. God knows I hate the MiniWorlds Theorem, right? Of quantum mechanics. This idea that every decision you make branches off another universe, and there are infinite numbers of universes of infinite number of views. That's an example. It's totally plausible that this is the way the universe really is, but it doesn't make any common sense to me that that's the way it is. And so maybe that's where we got to go with this next level. I mean, Albert Einstein, relativity is right, but so was Isaac Newton. About some things, though, Isaac Newton is wrong, right? Because we can't, Isaac Newton only gets us to a certain point in understanding the trajectories and the motions of things and the optics of things. To get any further, we need to invoke relativity. So we needed to get an extra step. So maybe we're at a point now where relativity is reaching a limit in what it can teach us about the universe, and we need something more complete. Einstein is correct and relativity is right within the regime that it works in, same as Newton's laws are valid and work in the regime that they work in. I mean, NASA uses Newton's laws way more than it uses relativity to get rockets to the moon. The only time I think it really invokes relativity is when they have GPS timing signals, because they need highly accurate clocks. So in certain stages, we invoke relativity, but mostly NASA uses Newton. So in certain regimes, certain people are right, certain theories are right. And so are we at a point, and I think we are, where we need to get beyond relativity and have something else? And this is that what Brian was talking about with this idea of maybe there's some other physics in play that we don't know about that gives us two different answers for the expansion rate of the universe. So maybe that is at play, and maybe there's something, I think, maybe beyond the domain of relativity that is responsible for that. But one thing's for sure, whatever it is going to really stretch our perception of how we think about the universe. And we need, so what would we use instead of our eyes and ears and our senses and our reasoning abilities and our common sense? I think we just have to rely on the math. And the only analogy I can come up with here is flying. When I was younger, I went through pilot training. I became a private pilot, and I was going to get an instrument rating. I never did because I never had the money, but I'm a private pilot. And in the training for that, they teach you that if you can't see outside of your windows for whatever reason, you get caught in a cloud or something like that, you trust your instruments. Whatever your instruments are telling you, trust those over what your body's inner ear is telling you, right? You could be upside down in a flat spin, and your brain is thinking you're climbing, right? You trust your instruments, right? That's the only analogy I can think of here that might go along with this. So in the case of the universe and studying things like this expansion rate difference, inflation, and all of the things that's involved in that, we need to trust the math. The math in this case is like the instruments on an airplane. We trust them because they're giving us the view of reality that we need to look at in order to survive. If you're a pilot and you're looking at outside the window and not looking at your instruments, and you're thinking you're climbing when in fact you're falling, you need to make corrections based on what the instruments are telling you, not on what your inner ear is telling you. So that's about the only analogy I can come up with here to explain what I mean. Because our common sense is going to fail us, right? We used to be, you look out, our common sense fails us even in things as simple as whether or not the earth is round, right? You hear all the time from people who believe in a flat earth that, well, it looks flat out there. When I look out on the horizon, everything looks flat. That's their common sense telling them that they're not living on a sphere. Move it a little bit further back, and suddenly you can see the curvature, and you're going, oh, okay, maybe it is round. So your common sense can't always be relied on, I guess, in this context. So I don't know. I've been thinking about this for a while, and I really do think that we are poised for a new kind of physics that fills in, or that picks up where relativity leaves off, and it might even join us with quantum mechanics. I don't know. There's certainly a gap there, right? So that we can't get those two theories to come together in a way that I think is mathematically meaningful. So I don't know. What do you guys think? I'm just sitting here rambling now. Let me chat with you guys. Hey, Bill, it's good to see you on Twitch. Flat earthers are people who can't be bothered to take more than one measurement. Yes. Hans is asking if I have instrument certificate, IFR or just VFR. I did have an IFR certificate for a while. I don't know if they ever expire, but what I am not is current. I don't have a current medical. And so I haven't flown in about 10 years, just because my life went in a direction that didn't leave me time for it. Charlotte hates flying in a small plane. So, but I live near a small airport, and I see them flying all the time. I can tell they're doing engine out maneuvers right over my property, because I'm hearing them flying along, and then all of a sudden the engine goes down, and then I hear it gliding, because he's doing a lesson, and he's teaching a student how to pick a spot to land and all that kind of stuff if the engine goes out. So yes, I'm a VFR pilot, private pilot. I never got I did take the test for instrument rating, but I took the written test, but I never took the flight test. So I think I could still fly an airplane. In fact, I know I could, if I were in one. When Charlotte's dad came to visit us for his birthday, we bought him I rode with him. We bought him a ticket on one of those seaplanes. It was the first time I had ever been in a seaplane, and we took off at a nearby lake, and we flew around Central Florida and looked at the area from the air. That was a blast. I would love to get a seaplane rating. I think that would be a lot of fun. But I did get a tail wheel certification where I could fly tail wheel aircraft. And I flew, and I took that test, and I flew to Leadville, Colorado, which is the highest airport in the continental United States. I think it's 11,000 feet, maybe higher. Anyway, that was a blast. Oh man, what fun that was. Anyway, we're not talking about astronomy anymore. Let's see. Captain Quinn goes, I flew myself. Good. Perhaps drugs will get us to the new physics. That's right, Eric. Maybe maybe that's what we need. Enhancement of some kind, don't we? We need some neural enhancement. So Neil's commenting or asking, electric aviation will make it more affordable than ever. No. I don't. And Bill says he can fly a plane. Cool, Bill. That's all. You just can't land it. You might want to get that skill down, Bill. Just me to you, man. You might want to, learn how to get those wheels on the ground. You might find that a lot more fun. But as far as electric aviation, I don't know anything about it. I don't know how it's going to make it cheap. There's nothing about flying that's cheap. The problem is not that the technology is that expensive. I mean, these Continental engines that a lot of these airplanes run on, they're just internal combustion engines. The problem is the maintenance and the inspections that have to be done on them every year to keep them airworthy. And to get that airworthy certificate, you have to spend a lot of money, and that's where the real expense comes in my opinion. And then you got to have a hangar to store the thing in, or tie downs, so to keep it from, have to have space at an airport that you're paying somebody else for. So all this stuff adds up. I mean, when I was taking lessons, I was flying in a Piper Warrior and a Beechcraft Sundowner, and I was spending at the time, and this was like in late 80s, early 90s dollars, like $60-70 an hour for the aircraft. And so when you imagine you've got to have 40 hours to get a private license, that stuff adds up, right? So it's just expensive. And then what do you do with it? I mean, you just got to go fly for fun. And I did all this out in Colorado, which was great training because when you're on the ground, you're already at 5,000 feet. So, you have to learn about density, altitude, and all kind of other cool things. So Sebastian Clark is coming. I believe the gravitational wave data will offer a way to alter or offer a total replacement of general relativity. Well, I think it kind of works together. Does I mean general relativity predicts gravitational waves, so it won't. It won't go as a replacement certainly, but I do think it will offer a another independent measurement of the acceleration of the universe, and I don't know much about it other than what I just said. But I think that people are using that new wavelength, that new eye on the universe to find a number for the expansion rate of the universe. So let's see. Okay. Galaxy is commenting. Oh, I should be doing this. I'm not doing this. They are searching it in something that precedes space itself. Consensus is that space is emergent and not fundamental. I fully agree that our thinking has to change fundamentally. Yes. Okay. I flew dozens of hours in a super decathlon aerobatic tail dragger. That is fun. That is a lot of fun. Let's see. I was okay. You also Captain Quinn flew. Bill's like, I can do anything once. Let's see. Yeah, walking away in one piece is definitely the hard part. So yeah, no, I did not see the electric turbine that BMW added, so I don't know much about this stuff. The engine costs of electric are way less per hour than gas. Yeah, I think the thing that I'm concerned about is with all things electric are the weight of the batteries, right? And yes, the engines are simpler, they're smaller, they're probably more powerful. Maybe not. I don't know if they're more powerful, but certainly it's storing the electricity to run them. And those lithium-ion batteries, I don't care who you are, they're pretty heavy, right? So. That's so. Abu Su is commenting. Physicists are waiting for new physics for decades now. You're right, and I think the problem is that they're waiting. Right? We need another Einstein. Where are the Einsteins out there in the world? Brian mentioned a lot of really smart people. All of them are brilliant, but we don't have any groundbreaking, new paradigm, scientific revolution thinking scientists out there, do we? Who can fill Einstein's shoes? Because that's what we need, right? We need a Newton. We need an Einstein. We need those kinds of people to get us to the next level. Or is it just one person anymore? Is it even possible for one person to be that smart to get us back? When you think about what Einstein thought up, this idea that time is not a constant, he built his work obviously on other people's work that were thinking along those same lines. So he had help too. But do we need collaborations now? Do we need big teams of people like at CERN or someplace like that to get us to the next big theory? A lot of people are enthralled with string theory and quantum mechanics, MiniWorlds, but these are all things that we have no hope of ever measuring based on the laws of physics that we currently have. These string theory ideas depend on things that are less than a Planck length long, and we know by Heisenberg and through other physicists that we're not getting that. You can never measure anything smaller than 10 to the minus 34, I think, meters. And these strings are supposed to be several orders of magnitude smaller than that. So we can't ever see them, can't ever measure them, yet reality is built on them. There seems to be, we need to make that leap somehow to get us into a new physics that says, well, actually we can see things smaller than a Planck length, and here's how. So I don't know how we would make that work, but whatever it is, I think it needs to be I think it needs to be, it's going to be very counterintuitive. A lot like quantum mechanics was, right? Quantum mechanics, if you think about it, It's very counterintuitive, but it's true, right? The Schrodinger's cat, it's not just is Schrodinger's cat alive or dead. Schrodinger's cat is both alive and dead. It's not an or situation, it's an and situation. And until you look in that box and you collapse that wave function, that you get one or the other. And that's very counterintuitive. So, oh, now you guys are talking about flying rules. That's funny. 30-minute flight time with 30-minute IFR reserve battery. Okay. So let's see. Bill Nash is still talking about electric flying. 15 kilowatts of thrust for 5 minutes on a flying squirrel suit. That's how crazy electric Swiss batteries tech have gotten. Okay. I did not know that. So St. Wesley, why can't you watch this later? Is there a reason? Okay. This is going to be. This is all going to be on. It'll be whatever you're on. This looks like you're on. Are you on? Are you on Periscope, or are you on Facebook, or what do you want? Because all of them are going to keep it, the recording of it, so it's not going anywhere. So you can watch it later. And thank you for stopping by and listening for the time that you have. Deep Astronomy, scroll up. I has a question. Okay. I'm scrolling up. John Suffel. Didn't I? All right. I'm scrolling up. John Suffel. Looking for John Suffel's question. He has a question. Here's what I see when I scroll up John Suffel. I humor them. I'm really scrolling up here. When did you leave it? Like last Tuesday? I post it again, man. I don't know where it is, so just post it again. You must have posted it like at the beginning of the chat or something, and we've had quite an active chat, so I can't find it. So post it again, John. Waiting on you. Let's all just wait for John. Waiting on you, John. This better be a great question, man. This better be like the question. Go ahead. We're waiting. You're gonna kick my ass, aren't you? Yes, John. You should use the little question mark. See? You did. You didn't. There's no question by John Suffel. Can I search on this thing? No, I can't. All right. That needs to be a feature. All right. Well, here's one I do see from Juan. Did you hear about the problems with phosphine detection in Venus from potential life? Any thoughts? It seems that the discovery has been disproved. It has. They went and looked again at the data, and they did not find that. They found that the way the data was processed the first time around was not correct. And it was a false positive. And so there is not phosphine on Venus, at least not in the concentrations that they claimed in the first paper. So people went back and looked. The second time, found did different kind of processing and did not find phosphine there. So that's the way it is. So here's something from John. A hydrogen explosion goes up, a petrol explosion spreads outwards. Bill, Schrodinger's cat, regardless of its state, is going to crap in your shoes once it gets out of the box. You could be sure of that. So, hey, Christian, it's good to see you. Yeah, we had a good conference. We had a good talk. Mostly we just talked about the stream that Brian did earlier in the week, which you know about. You should definitely go check out that stream. I haven't had a chance to watch it yet, so I don't. But he had all the big boys in there. Okay, but you're not going to repost that question, are you, John? Okay, fine. You're just gonna make me go through all of your comments. This is a good point, Neil. We do have smart people, but they work in derivatives in Wall Street. That's true. Very true. Oh, scroll up. Okay, so I found this one again. I'm just going to waste everybody's time looking for your question. You did use the question mark. Okay, I'm just going to scroll really fast looking for question marks. Red question marks. Here's one I came across. Kilian, yes, it is a Skywatcher Star Adventure behind me. I'm currently waiting on my Radian mount to get here, my Radian tripod that I ordered for this. So I want to use it on that. I bought it to use for my my PST, my personal solar telescope I have. Ah, here it is, John. I found it. Oh my God. Dan, I wish I had music, but then YouTube would totally boot me off of here, wouldn't it? Okay, so here it is. Here's John's question. You guys are only seeing part of it because it's a long one. John is asking, John Suffel from the UK, why do we think that our universe is the only one? Is it possible that somewhere out there another Big Bang occurred and a different universe exists? And the answer is, of course, it's possible. And the reason, and I don't think that most of us, I shouldn't include myself in those, most cosmologists are too busy, I think, learning about this universe than they are all the other possible universes that are out there. As I pointed out, in this, Leonard has written about this, right? And so has Stephen Hawking, right? The cosmic landscape is all about that we are one of a multitude of universes out there. And that there's a whole landscape of them out there, possibly an infinite number of them out there. The problem with this thinking and that is that it does nothing to help us understand this universe, because they were forever forbidden to us, right? We cannot ever hope to measure, see, interact, touch, smell, taste, eat, none of it, these other universes. It doesn't mean they don't exist, but for all practical purposes, they do for us. What are we going to do about it? We cannot prove definitively that they exist because we cannot interact with them in any way. Mathematically, yes, they are certainly a possibility that they're there, but they are not any practical sense something we can interact with. So I think the reason, the first part of your question, why do we think that our universe is the only one? I think that's because it's the simplest, right? But it certainly doesn't have to be the only one. I would prefer it if we were the only universe, only because I don't want to think about these other universes, especially if I can't deal with them in any way. It hurts my head and my common sense. But I already just got through giving you a tirade on why having, whatever the next level of physics is going to be, it's going to be counterintuitive. It's going to hurt our brains. It's going to be something that common sense isn't going to be able to wrap its head around. So, here I am saying all these things, and yet I'm trying to get something that I can latch onto. I'm biased, okay? I will admit it. I have no good reason for saying that we're the only universe out there, other than that's just what I would like it to be. But the universe is by no means constrained to what I want and don't want. So it's possible. All this stuff is. But the reason we think that it is for now, I think for a lot of people, is they're just trying to understand this one as well as they can. And in the course of doing that, in the course of understanding this universe, getting our handle on dark matter, getting our handle on dark energy, they are discovering mathematics that say, wait a minute, if this is true for the way the universe is, then other universes are possible. And then we get things like the MiniWorlds theory, or MiniWorlds interpretation of quantum mechanics. We get the cosmic landscape from Leonard Susskind. We get all kinds of things out of this that we get string theory and dimensions beyond count, right? So it's I know that's not a satisfying answer. It's just me blathering into the camera, but that's what I think the answer to your question is. And thank you for asking the question, even although you did it like 20-30 minutes ago. So sorry, it took me, boy, there's a lot of, you guys are really chatting, man. This is awesome. So thank you guys for attending. Fridays are a good day for this, isn't it? Geez, I'm getting a lot more attention on Fridays than I do on Thursdays. I don't know if that's because of the topic or Brian, or what, but this has been a really good turnout. So I want to thank you all the way from Facebook to Periscope to Twitch to you guys here on YouTube. I mean, there's a big disparity. I'm seeing about 95 viewers on Restream, but on YouTube I see 51. So there's a lot of people from other platforms watching right now. So I don't know, man. Leave a comment on here after this ends, because your chat will go away. Well, no, it won't. It'll still be there. Maybe I should do more Friday streaming, man. This worked out really well. Yeah. Oh, John just said, here it is. No, that's not it. So Astronomy Cast. So Fraser and Pamela are off today. So you guys got nothing to do. Okay. Thanks, man. No, thanks, John. Really. I'm glad you're here to just build up my confidence. No, I do appreciate it. See, Galaxy is trying to make me feel better. It's too late. John just crushed it for me. His nice, so thanks, man. No, really. Okay, so thank you, John. Good recovery. I appreciate it. No, I do miss you, man. We used to come on the streams, talk about telescopes. So it's all right, guys. You don't have to keep going. Okay. Oh, hey, Christian's live streaming tomorrow or Friday night. I might. I might. Thank you for the invite. Friday nights tend to be okay, but I don't know how this next Friday will come up. I tend to like doing the 3:00 streams, just because I get tired at night. And the last night I was supposed to stream on Clear Skies Network, but I had no internet, so I couldn't do it then. But I find that by 10:30 my time, on Clear Skies Network, I'm starting to fade. So I have to do energy drinks and stuff like that to stay awake. Alrighty. So, and first name, last name is commenting. One thing that people seem to underestimate is the lack of consciousness in the universe. The universe may exist without consciousness, but there's nobody to observe it. So the big philosophical ... And he's going to get to that, I think, in a minute, because he was limited on his chat. Is that's sort of the if a tree falls in the forest, does anybody hear it kind of thing, right? If there's nobody exists if nobody exists in a universe, it may exist without a consciousness, but without anybody to observe it, then is it really conscious? And yeah, you're right. That's sort of a hurt thinking synaptic thing to do. I don't know the answer. But so next Friday night. Yeah, next Friday night. Okay. Well, all right, Christian, I'll tell you what. Let's coordinate a little bit. I'll show up on your channel, and maybe you could restream to mine, and we'll just sort of work together on that. I don't know what you want to talk about, but I'll tentatively commit to next Friday. Is it 9 p.m. Eastern? And Glacia is saying, is it because of ad infinitum? There is one God or one nature. That's why there is one universe, or a multiverse with only different parameters still being one. Yeah, good. That's another good reason. So that's a good answer. Also, John, do it on Fridays. Okay. If a tree fell in the woods, will there be a sound? Yes, there is a sound, just no one hearing it. So yeah, I know. But if the universe, we got to talk about what we mean by a universe with consciousness. Is it a universe that is conscious in and of as a characteristic of itself, or is it a environment in which consciousness can thrive? So we got to be careful how we talk about this. But yeah, if we do 9 p.m. Eastern time, we lose all the European guys because it's too late for them. They go to sleep. Thank you, Tony. You're awesome. Also, yeah. Okay, let's talk offline. So I'll tentatively commit to whatever you want to talk about next week. If it's yeah, this is something YouTube will definitely go with. If it's not posted on YouTube, did it really happen? Yes. Well, according to yeah, right. So I'm living this reality right now. I'm posting things on a lot. The only reason I'm still on YouTube and is I'm doing this kind of content. Otherwise, YouTube wastes my time. Right? I can't be doing YouTube with a lot of all these videos I used to make, Space Fan News, all that. Screw YouTube. I'm doing it somewhere else. So I'll stream on YouTube, but I'll also stream everywhere else, and I'll post my other videos on Library. So if I ever make them anymore, I am going to start making Space Fan News again because I miss doing that. Comic Girl, good to see you, man. The internet never lies. No, it does not. That's right. Thank you. She's on Twitch. So that's right. The internet always is right up there with me. YouTube is going down, says Neil. Carl, if you are there, can you drop off the crack on Tuesday as my mom has an appointment with the doctor so I can collect it like we planned? Cheers. I love it, man. All right. Good job. Yeah, get your crack, man. Get your crack off my channel. You hear that? Carl, drop off his crack so Paul can have some. Okay. Hackers of the world untie. Oh, sorry. That's dyslexics. Okay, guys, I'm going to head out. This has been fun. I want to thank you guys for showing up. Give me feedback on Friday as a day. I usually do Thursdays because I have been since forever. I'm probably still going to do my big streams, the ones that involve like the AAS and stuff like that on Thursdays, just because that's the day that people want to do it. But I might do a Friday stream that's maybe just me or something rambling on. We'll see. All right. Okay, I think that's it with the chat. I'm going to go ahead and sign off. Thank you guys so much for watching. My name is Tony Darnell. I run deepastronomy.com. And hang on. Where'd it go? Where's that? Oh, darn it. Here he goes. There's a big difference between those two words, guys. Which did you mean, Paul? That's what I'd like to know. Okay, off, guy. There's a big difference between those two cracks, just so you know. All right, everybody, I'm out of here. Thank you all so much for watching. Look for us I'm on Tuesdays every day on Twitch, every week on Twitch. It's called Tony's Twitch Tuesdays, 3:00. T-Cubed, join us there. Twitch only. Also, coming up on December 3rd, I have a hangout with the Lisa group. The Lisa ESA is leading a mission called the Laser Interferometer Space Antenna to measure gravitational waves in space. And I wanted to know more about the status of that mission, so they've agreed to come on December 3rd, Thursday, 3:00 to talk about it. Members of the ESA collaboration will be on hand to do that. I would also like you to, if you have an Alexa device, I don't know why you would have an Alexa device. I don't even know why I have one, but I do. I have an Alexa speaker thingy. I think I got it for free as a result of ordering something on Amazon. And I'm doing Space Fan News as an Alexa, what do they call it? Flash briefing every week. So if you say, Alexa, give me a flash briefing, and if you go on the app on your phone, the Alexa app on your phone, again, why would you download this on your phone? I don't know. But if you did, and you decided you had an Alexa app on your phone, you could select Space Fan News on your flash briefing. And every day when you say, can I get my flash briefing, you'll hear Space Fan News. So please, is on there. I did it because I wanted to learn how to make an Alexa skill. Okay. So I don't love Alexa any more than you do. I don't trust it any more than you do. In fact, I have it in my guest bathroom. That's where I put the Alexa speaker. And I warn our guests that it's there. But I don't want it listening to me in my living room. So it's definitely not in my living room. But I do put it in there so that I can make sure the flash briefing works and that the sound is normalized properly and all that stuff. So anyway, so just letting you know it's there. If you've got an Alexa, please listen to Spaceman News and give us feedback, give us a rating or something. Do whatever you do on Alexa. Okay, guys, I really am leaving now. Thank you all so much for watching. Have a great weekend. And as always, keep looking up.